Sneha? Sneha, are you there? Venkat, have you completed?
Sir, I need your help on that part, sir. I was a little confused.
Okay. Venkat, have you completed? Venkat, have you completed? Venkat R and Venkat. So anyhow, you have to complete these all programs. This is the very basic programs. Basic and some standard programs is also there. So you have to complete this Python programs, programming problems. So you have to complete. There is around around 13 program is there. This is the standard programs you have to complete. This is just like whenever you are going for any fresher interview, so someone is asked like, hey, write the program of palindrome, Armstrong. Okay, so these kind of programs you have to write quickly without any delay, because this is the very basic program, initial level of testing, like you are interested in programming or not. Fibonacci series, factorial, dot product, cryptogram. These are the bubble sorts. So these are the basic programs anyone can ask. Okay, so you have to do some practice, basic program practice. Okay, so today we'll start. Today we'll start a level for KNN algorithms. Level for KNN algorithms. Okay. So as of now, we have completed that their mathematics. Okay, what is Euclidean distance and what is k is equals to what is Euclidean distance? We have completed like how we'll come find out if the input is given. Okay, experience is given. On the basis of experience, the label is also given. So you can say that this is supervised learning or unsupervised learning. If label is given, so this is supervised learning, and in label, if you are able to identify the output, like if your output is definite or discrete, so you can say here this is the supervised classification learning or regression learning. Supervised classification. If your label is defined but your output is continuously changed, so you can say here this is the regression problem. So we are pretty much aware about what is supervised, what is unsupervised, what is regression, what is Euclidean distance, and what is Manhattan distance, what is Minkowski distance. Okay, so today we'll see importance of KNN neighbors. What is KNN algorithms, and we'll see. So give me 5 minutes time. Okay, I will start. Anyone in hurry? Like have to go to office and anyone? So give me 5 minutes. Yeah, give me 5 minutes. Fine. Okay. If you are getting the 50% chance, 50% probability is good and 50% probability is bad. So you have to always go with bad. This is the concept. So instead of high confidence, less confidence is considerable, right? So if someone is taking like a hey, this way is risky, 50%, you may be, this is the chance of 50%, 50%. So always think like a 50% you can lose. So you have to go with that philosophy. Got it? Then after you have to tell like a here instead of k is equals to 4, what will be the output? It will be good or bad. Got it? So that I will think you will getting my point. Yeah. So let me start some. I want to show what is k nearest, and then I will move. And then I will move. So as of now, we have already gone through with the data sets. Kindly go to that parts first. Then only I will describe. I will describe it and then come back again. You have to think. You have to think at least from your own side. Got it? You have to think from your own side. Okay, so you can see here for working with the KNN algorithms, K nearest, if you want to know what is K nearest algorithms, K nearest neighbors, you can say like a KNN algorithms. So KNN means this is called K nearest neighbors. What is the KNN? It is say like a K nearest neighbor is a simple algorithms that stores all available cases and classifies new cases based on similarity measures. Like let's suppose whatever similarities is already given on the basis of that you have to calculate within Euclidean formula. Not by default it's work on Euclidean, not on Manhattan. So by default, it calculates the distance using Euclidean formula. So you can see here, this is our KNN, K nearest. So what is the meaning of KNN? KNN means K nearest neighbors. K nearest neighbors. That means I will give some nearest neighbors according to that according to your neighbor's output that you have to analyze. Let's suppose I say that you have to take information from 4 neighbors. So you have to take the information from 4 neighbors. Let's suppose I have to take like you have to analyze you are good and bad. I will analyze from your 4 neighbors. Even though let's suppose you are taking some PCC, police clearance certificate. So that PCC, so for a passport office, the information goes to that police department. They comes to your home and they ask 2 or 3 neighbors, hey, you are good or bad. According to that, they are sensing you are good and bad. You are getting my point. So same as it is here, it will take some data from nearest neighbors. Even though that police guys will not take a report from your relative, they can take report only from your nearest neighbors. Nearest neighbors. Got it? So what is K nearest neighbor? So K nearest neighbor is a simple algorithm that stores all available cases and classify new cases based on similarity measures. So you can see here K nearest algorithm is in pattern recognition. K-nearest algorithm is a non-programmatic method used for classification and regression. So this algorithm is used for both classification and regression. This algorithm is used for both classification and regression. So before coming to that point, I want to know, I want to show how can you know that this is what is k nearest algorithms according to that your code, according to code. What data sets is required to work with k nearest. So first of all, in this k nearest, we'll see KNN classification. So before that describing, I want to show with the code, and then we'll come back again at that this chapter. So then we'll go back on this chapter again. Having distance, okay, and then brood KD tree and ball tree and random tree, and what is the KNN is a non-programmatic method or programmatic method. So you can say the KNN is a programmatic method. The KNN argument algorithm will not accept below values. I will describe these things later point of views. I want to show some line of codes and then we'll come back. Got it? So it will give more clarity. So it will give more clarity. Before that, I want to know there is in this data sets there is two data set. I want to describe there is two data set. One is train and another one is test. Train data and test data. So what is the meaning of train and test? What is the meaning of train and test? Once again. So I want to describe what is the meaning of train and test. Got it. So what do you understand by train and test? So let's suppose I'm giving you a training here. Okay, I'm giving you a training here, and I say like in your child, in your I'm not taking that examples. Let's suppose I'm giving you training here. I I I described here two programs. I describe here two programs. Okay, and I say here you have to write three more programs on the basis of these two programs. So first, what I did is I completed your training parts. I trained you first, and then on the basis of that, I want to test you. First, I trained you, and then on the basis of that, I want to test you. That means you can say here in your classroom, let's suppose sometimes in classroom there is two things like one is, let's suppose in your class teachers come to your classroom and and explain two programs. Hey, this is the way for you writing the programs for find out the odd numbers or even numbers. Okay, on the basis of that programs, I want to test that you are getting my point or not. I want to say that hey, you have to write the program of prime number. So same things here. There is two concept is called train and test data. Train and test data. So what is the meaning of train? Train means like there is some data set which is called train data. That means first I will train that data. I will train the data according to algorithms. Okay, according to programs. Through the program, first I will train the data. Once the data will be trained, okay, so then I will test the data. Even though let's suppose I have some data sets. On that data sets, let's suppose that data set is 100%. We have 100 data sets. In this data set, I want to divide this data set into the two parts. One is 70% and 30%. That means 70% is my trained data and 30% is my test data. That means that means I trained this data 70%. On the basis of that, I want to test that data. This is the actual output is coming or not. First of all, I trained the machine. I trained to that machine 70%. 70% training I have given. I trained to that machine, and I want to test that. Hey, this machine is giving the actual output or not. Whatever I am expecting, this actual output is giving from that machine or not. So this is called train and test. That means this trained data is seen data. You can sometimes in terminology it's called like a seen data. Seen means like we are seeing that we are experience we are we are taking experience how to tend that machine. On the basis of that, I want to test that machine. Hey, the machine is giving the proper output or not. Is my training is successful or not? Same as it is sometimes I trained you, and then after that I give some assignment. Why I'm giving that assignment is like I want to test you whether you are getting my point or not, whether you and me are at same page or not. Same as it is here, what we'll do like first we'll train the data, and then test. So let's suppose I here I have this line of data sets. Okay, this is the data set, and I want to train this data sets. Let's suppose let's suppose this is 90% I trained, 90% I trained, and then 10% I want to test. Then next iteration I want to train 80% and 20% I want to test. Then I want to train 70% and 30% I want to test. Then I want to train 60% and 40% I want to train. So the ratio will be, again, let's suppose in our data, let's suppose we have 80 data sets, 80 elements. So let's suppose you say like 70% is the trend data. So what will be the test data? Test data will be 30%. Let's suppose I say you 30% is our trend data. So what is the test data? 70% is the test data. So if you are giving more training data, so testing data output will be more accuracy. Because let's suppose I say like I trained you, I give you 5 programs. On the same basis, I want to say that you have to write only one program. So accuracy will be more. But let's suppose I described you only one program, and I say like you have to write 5 different programs. So maybe the accuracy will be lesser. Same things in our programmatic will be getting the same result. So are you any confusion with train and test data? What is the train data and what is the test data? Any confusion? Tell me. Anyone? What is the trend data? What is the test data? Anyone? Yeah, I'm giving enough time to you have the thing. Lakshmi Priya, are you aware about train and test? Any confusion? What is train and what is test?
No confusion, sir.
Okay. Okay, got it. So now I want to see what is k neighbors. So from this, I have to import. What you have to import, like you have to import. There is a, for machine learning, I told that there is one package is called, what is the package? The package is called scalar. The package is called sklearn. So from sklearn, dot from sklearn, you have to if you want to know what is sklearn, you can see that from sklearn I have a one package is called neighbors. From sklearn I have a one package is called neighbors. Ne, why it's not okay. So you can say here sklearns.neighbors. What is the package name? From sklearns you have to put right a neighbors, and then you have to import which one? K, you have to import k neighbors, k neighbors. You can type it k neighbors. Let me execute here. Option should be given. KNIGH. Yeah. So you can see here there is two things. One is k-near classifier and another one is k-neighbors classifier, and another one is k-neighbors regression. So first we'll see what is KNN. KNN means k neighbors, k nearest neighbors we'll see. So k neighbors classifier we'll see. By its comes classifier. I want to know what is k. What is? I want to know what is k. I want to know what is k neighbors classifier. So I want to check here. So today we'll see what is k-near classifier. You can see here by default the neighbors is taking like a, what is the neighbors? It is taking. You can see by default the neighbors in k-neighbors classifier, how many neighbors it is there, number of neighbors is taking by n underscore neighbors is equals to 5. A underscore neighbors is equals to 5. Then you can see here what is the weight. What is the weights? So I described weights. So this is the uniform weights. Uniform. This is you can see here. This is the uniform weights. Next one is you can say algorithms. Next one is say you see here leaf size. Next one is say p is equals to 2 and metric is equals to Minkowski. So today my goal is I have to describe two things only. What is neighbors and what is matrix and what is p is equals to 2. So in previous session I have already described if p is equals to 1, it is called Euclidean distance or Manhattan distance. So if p is equals to 1, yeah. So if p is equals to 1, it is called Manhattan distance. It is called Manhattan distance. But here you can see here p is equals to 2 and metric is Minkowski. So in Minkowski, if p is equals to 2, so you can say this is the Euclidean distance. This is the Euclidean distance. So by default, the KNN or k neighbors classifier, it takes the neighbors is equals to 5 and neighbors is equals to 5 and p is equals to 2 means like a it is take like a distance, like a Euclidean distance. It is calculated through that Euclidean distance. Got it. So let me delete it. Euclidean distance. So once we'll come here, you can see here doc string classifier implementing the, what is the classifier? K nearest neighbors word. N underscore neighbors, it is take int value optional, that means default is 5. Default is 5. Numbers of neighbors to use by default K neighbors queries is 5. 5. What is weight? You can say here string or callable optional. I will describe this weight later. Okay. Weight function, it is for prediction. I will describe later, and I will describe uniform also. Coming to that, uh, lip size also I will describe. You can see here p is equals to integer and optional default is equal to 2. Power parameter of Minkowski matrix when p is equals to 1, this is equivalent to Manhattan distance, and sometimes called this is the L1. And Euclidean distance, if this is called L2 distance. Euclidean distance is called sometimes called L2 distance, and p is equals to 2. So if p is equals to 2, you can say this is the Euclidean distance and sometimes called L2 distance. So you are getting my point. So coming to that, yeah, p in your formula, I have already described that. This is the your form. This is the formula in. This is the formula in first chapter only. Sorry, not in first chapter. No, P have to pass. Let me complete it. This is the Minkowski formula. In this Minkowski formula, there is P is just like a notations. And P you can push pass anything. So you can say, yeah, either P is equals to 1 or P is equal to 2. So if you are taking this in Minkowski formula, if you are passing, you have to pass 1 or 2 only, not 3. You can see. So in this Minkowski formula, let's suppose you are passing 2, so that is considerable like this is the, it will become a Euclidean formula. Minkowski is nothing. It just combined formula of both Manhattan and Euclidean. Yeah, by default, most of the time by default, even though I want to show here, by default, it is taking p is equals to 2 only. You can see what is p is equals to 2 only. You can see this is a p is equals to 2. This is the system generated function. This is the system generated parameter is passing. So if you are not passing p is equals to 1, it will by default take p is equals to 2. And if you want to do know the detailed description, you can see here. So p integer optional default, this is the default value is 2, and if you are p is equal to passing 2, you can say this is the Euclidean distance. Got it? Yeah. So same as it is, you can see here there is x is equals to 0, 1, 2, and 3. X is equals to 0, 1, 2, 3. So and y is equals to, so this is x values, and this is after the classifier, this is y values. So I will describe what is x, what is y. So x is nothing but you have to think there is a standard words, standard digit or characters will used in our whole of the algorithm. X means input. You have to remember, X means input data and Y means output. Got it?
X means input and Y means output. And you have to follow some standard also. X would be always capital letter and Y, which is the output, is will be in a small letter. So this is the standard as per documents. This is the standard. So you have to think in this way. Got it? Got it? Right. So let me describe. I want to describe some input data. Okay, and then I want to describe here. Let me describe. So let's suppose you want to import some required modules. So you have to import import. This is one required module. You have to import required modules. So which modules is required? First of all, you have to suppose you have to require import for some data set from sklearn. You have to import which one? Import data sets from sklearn. You have to import data sets. Then from sklearn dot you have to select a model also, model selection. So our model is train test model. Okay, then you have to import train underscore test underscore split, because whatever data set will be taken from data set, I will divide that data set into the train and test data. Train and test data. First, I will train the data set and then test it. Then here I have to required for import numpy also, numpy as a np I have to require. Then I have to import from sklearn dot neighbors, and then I have to import which one? KN neighbors classifier I have to import. Then I have to import from sklearn for accuracy result. I want to know, once I trained my machine, I want to know after the testing how much accuracy the machine is giving. You know, I trained the machine, then I want to know after the testing, I want to know after the test, I want to know how much machine gives the accuracy. So for this, I have another package from sklearn.matrix, and from there I want to import accuracy score. So this modules is required. This module is required to what we'll do like then we'll come back to that KNN algorithms. So what is things? First we'll see that some practicals. First, I will try to import some data set. Let's suppose we are already aware about the iris data set. So first I want to load that iris data set. Okay, iris data set. Then I would like to apply some model selections, train test split. That means first I will train to that data and then test that data. So let's suppose I want to train 70% data and 30% I want to test it. Then after I want to know accuracy from the actual and machine level, because we have actual data. Okay, I want to know after the training what accuracy level giving by the machine in testing. You are getting my point? I want to know, let's suppose I trained you. I trained you for 5 programs, and I want to give 2 programs. Okay, I'm the teacher and I know what is the accuracy, but from your end I want to know what percent what percentage of in test, how much you have attempted, what is the accuracy of your test. So that's why we'll see here accuracy score. Got it? Got it? Yeah. So after this data, we'll see how to load and understand the data. So next step is, this is the required module. Next step is how to load and understand the data. So for loading the data, how to load the data. For loading the data, we are pretty much aware about how to load the data. We have a data set dot which one I want to load, which data I want to load, iris data. So I can load this iris data into, let's suppose I have taken one variable called iris. So here I have already loaded iris data. In iris, there is one, you have already know that key. Should I, if you want to know iris dot keys, if you want to print here iris dot keys, you can see here in iris keys we have a data target name description. So whatever data is for input. Whatever data, this data is just like an input. So I want to take that data into x is equals to iris and put here data. So that data is, I want to take that data into x and I will consider this is the input data. And then I have a y value, this is the output. So I have already described what is the target, whatever the target, this target is called output. I have already described in previous session. I want to put into the target. So x equals to x this is our output data, and this is our, sorry, this is input and this is called output. Got it? So I have a data set x and y. Then next step is, I want to split data for training and testing. I want to split data for training and testing. That means for training and testing. So how can we do that? I want to split. Hey, Arul, maybe someone have to go to that office also. So is it fine to continue, or we have to continue tomorrow? So for you, I don't have, maybe someone is working here now. Pratik, Lakshmi Priya,
Yeah, yes, sir.
you have to go to office.
Yeah. Can we continue tomorrow?
Okay, yeah,
Me
yeah,
too,
sure.
sir.
Yeah, yeah. Okay, sure. Thank you. We'll continue tomorrow.